Here we've been given a combination of functions or embedded functions. So we have f of g of 0, and we've been given a table for f and a table for g. So it's important to recognize what's on the inside and what's on the outside. So I'm just going to color g here. I'm just going to shade it with the green. So this represents the the f, and I'll do the g with blue. So there's my g function. In this case, it looks like this. Okay, there's my g function here. Okay, so when I look at the first one, a, it says g of 0, f of g of 0. What that means is I'm going to take my 0, I'm going to put it through my g function, I'm going to get an output, and that output goes through the outside function f. It always goes inside out. And I want to know what my output is. So I start with 0, okay? My output for g is 5. That output has to go into the f function, and the output, when I input x is 5, I get y is 3. So when I work this out, this is equal to 3. Okay, so I'm just going to maybe move this over a little bit, move that down. Actually, I'm just going to leave it up here, and then this 3 is what we've just solved for here. Okay, so that's how it works. So we can do these other ones in a very similar way. So I'm going to first start with in this case for b, the green is on the inside, so my inside function is f. So I'm going to start with my input of 5. So there's my input of 5. My output's going to be the 3 here. So once I get the output of 3, that output has to go into the g function. Well, I'm going to take that output of 3, it becomes the input to the g function, and from there I'm going to get an output of 1. So the answer here then is 1, and that comes from this one right there. Inverse. Inverse means you do the opposite, or if f goes this way, the inverse goes in the opposite direction. So I'm going to be going in this direction. Again, I need to observe that I'm starting with g. But if it's going in this direction, what that means is the 4 represents an output. Okay, this 4 here represents an output. So I need to look for 4 as an output in the g function. And I'm going to take that output and I'm going to go in the opposite direction. So I'm going this way to get the 2. Okay, so that's going to be my output. So then from there, I'm going to do the inverse of f. So I need to take my 2, and that is the y value. So I replace it with the y value here, and then we go backwards through the function to get to the 3. So the answer to this is going to be 3. So I started here, I went to 2, I went to this, that output here becomes the input here, and then I end up with the 3 here. Okay, and it all went in this direction because of the nature of the inverse. So the last one here, we are looking at the inverse of g. So we first do the inverse of g and then put that through g. Well, a property of inverse is that if we have the function g, the inverse will undo it and vice versa. So here, if we start with g, okay, we're going to start with the output. Here, we go to 1, and then we apply g to it. We go back to 0. So the function g and its inverse undo each other. So what I start with is what I end with.